In this video, we're going to practice charting and graphing plots using patterns. First, let's see how this pattern of green blocks changes each iteration. The first picture has 5 blocks, 3 blocks in one row, flanked by 2 wings at the top and bottom. The second picture has 10 blocks, 2 rows of 4 blocks in the center, flanked by the same 2 wings on top and bottom. And the third picture has 17 blocks, 15 in these 3 rows altogether, flanked by 2. What is the pattern? We can see that the 2 wing blocks stay constant throughout. The number of interior rows, which is the flat set of blocks, increases by 1 each time, and the number of columns, which is the vertical blocks, increases by 1 also. Extrapolating, or going beyond the data that we directly have, we can see that for x is equal to 4, there will be 4 rows of 6 columns plus the final 2, which is 26 blocks altogether. For x equals 5, there will be 5 rows of 7 plus 2. 5 times 7 is 35, plus 2 is 37. For x equals 6, 6 rows of 8 plus 2, or 50. And for 15, we'll see that we have 15 rows of 17 plus 2. 15 times 17 is 255, plus 2 is 257. Can you think of an equation that represents this pattern? We have x rows times 2 more than x columns plus 2. This is called a quadratic equation and is different from the linear equations you've been working with up to this point. Quadratic equations are identified by the square of the variable as the highest power. We can see if we distribute this x across the parenthetical, we'll end up with x squared plus 2x plus 2. This is called a quadratic because it has a square as the highest exponential power. There are higher order polynomial functions, polynomial meaning many numbers. Graphing this using these ordered pairs, we put our first dot at 1, 5, and then we go to 2 up to 10, 3 up to 17. If you'll notice, I haven't done the y-axis by 1 like I've done with the x-axis. That's because the number blows up so quickly that in order to get enough of the trend line, I needed to shrink the window a bit. This will affect how the line looks, but it is still correct to do it this way. For 6, we go all the way up to 50. And then for 15, which isn't on this graph, we're well past the boundaries of this. So we can see if we tried to do a straight line, it wouldn't fit. So up till now, the linear graphs you've been doing have been able to fit with a straight line. However, with quadratic equations, we want to put a smooth line connecting all the points, and you can see that the line gradually increases in steepness the further it goes on. This line is called a curve. Notice that it isn't straight like a linear graph, but they are both forms of lines, a line being a specialized curve, which just happens to be flat.